Hey everyone. So in this week's competitive programming solution series, let's look at an easy problem that we can solve using the stack data structure. So without further delay, let's get into the problem. So we need to find the minimum string length after removing specific substrings. So our input string will be capital English letters, and the patterns we need to remove are A, B, and C, D if they are next to each other, like as one units. AB as one unit and CD as one unit. And then we have to return the length of the string after we have performed the removal operations. We can perform one removal at a time. The thing is, a removal can result in the pattern repeating, which we have to iteratively remove. So as we can see in this example, uh, when we perform the first removal operation, we will get rid of the initial AB. So that will result in the FCACDB string. And again, there is CD in the middle. So once we remove that, we will have this FCAB, and this will result in an AB pattern, which after removal, the final result will be 2. And in the second example, there is no pattern here. There's no AB or CD next to each other. So we can't remove anything. So the entire length is the minimum length of the substring. So we will return 5. We can solve this problem using a stack data structure. So given the input, we can traverse one character at a time and add our character into the stack. So let's say we are at A now, and the stack is empty. So we put A into the stack and we keep track of the last one in the stack. Now we move to the next character, which is C, and at the top of the stack we have A, so we can construct a pair of characters taking the topmost character from the stack and the incoming character, so that's A and C. So this way we can compare it against the pattern that we want to remove from the string. In this case, the patterns we want to remove are AB and CD. The pair AC doesn't match any pair that we want to remove, so we add the character C to the stack, and now C is at the top of the stack. We keep moving through our input sequence to the next letter D, and now let's construct the pair, which is C from the top of the stack, and D, which is the current character we are iterating through. CD is a pattern that we want to remove. So in this case, we will pop the stack and keep on iterating through the input sequence to the next character. So B is our current character now. So let's take that, and now we will do the construction as usual. So from the top of the stack, let's clear this out. And from the top, we have A and our current character is B. AB is also a pattern that we would like to remove. So when we face that situation, we usually pop the stack again. And then we move on to the next character in the input sequence. Now we have reached the end of our input sequence, and the current character is F. And also our stack is empty, so we push it directly into the stack. And now our length of the stack is 1, and that is the answer to this problem. So this is how we can use stack to solve this problem. Let's implement the stack idea that we discussed using a short Python program. So I'll initialize a empty list that I'll use as the stack data structure. And then I'll define a separate function where I can determine if a current constructed input pattern matches the pattern that we want to actually exclude. So the patterns that we want to exclude are AB and CD. And I'll just check if our input pattern is in the patterns constant. Now I'll construct the pair that we want to send into the comparator function. But before we do that, we have to first iterate through the input sequence, right? So let's do that. And for each input character, uh, The second thing in the constructor thing would be the character, and the first thing is the if the stack is not empty, then the top of the stack. Otherwise, I'll just send an empty string. So if the pattern matches uh, with the incoming pair, then we have to pop the stack, right? So that's what I'll do. And then I'll continue with the input sequence. If not, I'll add the character to the stack and then return the length of the stack. So this should be our implementation for our discussed algorithm. Now let's run this program to see if it works. There's an error, stack, and okay, I forgot to actually append the character. So let's append the character and run it. Yep, so it works as expected. We get the expected results, 2, 5, and 0 for the respective input sequences. So this is how we could solve this problem. And that's it for today. Speak to you in a different video. Bye.